Right, so here's page 3 of lesson 3.4. And now we're going to try to find the equation of a line given 2 points. Now these points the numbers are much bigger, right? Graphing this is going to be much harder to do than our previous problem. So how do we do that? So there's a couple of ways we can find the rate of change. Now the first thing I'm going to do is I'm going to put these points into a table. So our first point is 9:27. And our next one is 18:39. Now, what we could do is what we've done with tables before. How did we find the rate of change in the big race, or with the plant growth, or with the table? The swimming pool that was being filled up. Those were all tables, and we used those to find the rate of change. Well, we looked how much is. Well, first of all, is this increasing or decreasing? We're going from 27 to 39. Well, that is definitely increasing, so I'm going to put a plus here. How much did it increase by? Well, if I think about it, if I add 2 to 7, that'll get me to a 9, and if I add 1 to the 2, that'll get me to a 3. So it's actually increasing by 12. You can get the same answer by just subtracting. What about here, 9 to 18? Well, that's going to be increase of 9. So I actually do have my change in y over my change in x, which is 12 over 9. Does this simplify? It does. If you put 12/9 in your calculator as a fraction, hit enter, it will simplify it. What is it going to do? It's going to divide the top and bottom by 3, because 3 is a common factor for both. 12 divided by 3 is 4, and 9 divided by 3 is 3. So this is your simplified rate of change, or your slope. Now, how do we find the y-intercept? I'm going to draw a line here. I could go back to this table. I'm going to recreate the table again. And I'm going to do a 9 and an 18 and a 0. Now, this was 39, and this was 27. This increased by 12. This increased by 9. Okay, so going down, this adds 12 and this adds 9. But what if I go backwards? If I subtract 9, that does take me to a 0. And we know that the start value occurs when x is 0. It's whatever y is when x is 0, that's going to be your start value. So what if we backtrack this? This would be 12 less. So that would be 15. So here we do have a start value. And that start value is 15. So I can now write my equation, y equals, put in my slope, 4/3 x plus the start value, which is 15. Now I cut this in half because there is another way to do this. And this method can be a little more difficult, and especially difficult if you backtrack. If you backtrack and it doesn't hit 0, then what do you do? So I have to show you a different method. So the first thing I'm going to introduce is an equation for the rate of change. Remember we talked about m represents the slope or the rate of change. And this is what we're going to do. We're going to put y sub 2 minus y sub 1. The reason I'm saying sub, I'm putting numbers that are shifted down. These are not exponents. They don't belong up here. They need to be small and shifted down on your variable. I'm going to do the same thing here. X sub 2 minus x sub 1. And now I'm going to explain what that is. I'm going to write our points here. 9:27 and 18:39. Now each point has an x value and a y value, right? So these are both x's, these are both y's. So how do I tell the difference between which ones? If I said what's the x value, you'd be like, well, it's either 9 or 18. Sorry, I apologize. I'm doing really bad about not showing everything on the page. I apologize. Okay, let's do that again. So if I ask you for the x value, you'd be like, well, which one do you want? Because there's an x value of 9 in this point and an x value of 18. So how do I specify which one I'm talking about? And this is where mathematicians came up with a subscripted variable. If you have multiple values for this variable, to distinguish, you could put a 1 here by this x and a 1 by this y, meaning these are the x and y values of the first point. And you could put little 2's here to say that these are the x and y values of the second point. So we're going to use this equation to find this same slope of 4/3. And we're going to just plug in the values for each of these. Y sub 2 we've defined as 39. So we're going to put 39 here. Then there is a minus sign, so put a minus in. Then the y sub 1 is 27. We'll put a 27 here. Now on the bottom, let's do the x values. X sub 2 is 18. And then there's a minus sign, so we'll put a minus. And then x sub 1 is 9. This is the same math that you did over here in the table. 39 minus 27 is 12. 18 minus 9 is 9, and this does reduce down to 4/3. So you do wind up with the same answer using this formula. I do want to caution, when you start getting negative numbers that you're plugging here, you have to be really careful to make sure all your negatives are accounted for. We'll talk more about that in other problems. All right, so let's go and continue. We're gonna now need to find the start value. So we know the slope. Now we need to find the start value. So we're going to use y equals mx plus b. This equation, it's called the slope-intercept form because you can see the slope and the intercept, the y-intercept. But what we're going to do is we're going to plug in the slope that we know. So I'm going to put the 4/3 here. And what I want to find is the start value, which is represented by b, the y-intercept. So all I need to do is plug in an x, y value, a corresponding x and y value, in place of x and y, and then solve for b. Well, I have two candidates right here. I have 927 and 1839. I could do either one. Let's use this one since the numbers are a little smaller. So 9 goes in for x. So I'm going to plug 9 in here. Remember, if I plug in a whole number, I like to keep it even with the top. And then the 27 can go over here. All right. Now let's simplify. 4 times 9 is 36. The 3 is still here. Remember, you only multiply the 9 to the numerator. 36 divided by 3 is 12. And then I'm going to flip the 12 over to the other side, so we're solving equations now. And 27, I apologize, I wrote 15 instead of 12. You'll understand why here in a second. So flip the 12, it becomes negative 12. And then 27 minus 12 is 15, which is your y-intercept. The same thing we got here, and we backtrack on the table. So you do wind up with the same value here. When you flip the 12, it becomes negative. 27 minus 12 does give you the 15. It's the same y-intercept that you got. So your equation here is 4/3 x plus 15. All right, well, what if we use this problem? I'm going to go ahead and just block off an area here. What if I chose this point instead, 1839 instead of 927? So I'm going to put in my 39 here for y, 4/3 for x, and 18 for the x value. I apologize. I think I said 4/3 for x. I really need to not do these videos this late at night. I apologize. So x is 18, y is 39. This is still the rate of change. I don't know why I put 15 there either. Geez. I know that's the answer. I think that's why, but I want to find the answer using this point. All right, so now we're going to have to multiply. And we're going to have to multiply the numerator. So 4 times 18. We multiply that, we're going to get 72. So 72 is our numerator, still over 3. Bring down the 39 and the equal sign. Now we have to divide these. 3 goes into 7 2 times. With a remainder of 1, that's a 12. So 24 is the value that I get here when I divide 72 by 3. And then I just, to finish solving, I need to flip the 24 to the other side. So this becomes a negative 24. And when I do 39 minus 24, I get 15. So once again, it didn't matter which pair of points you chose to solve this problem. You will get the same answer either way. All right, so let's apply this to a problem that is a little more real life. The other problem was just numbers, right? So now we're actually looking at a situation. We have a car rental company. They charge according to a linear function where the cost depends on the number of miles driven. If driving 20 miles costs $55 and driving 31 miles costs $63.25, find a linear equation representing the cost, y, where x is the number of miles driven. So cost is what y represents, and x represents the number of miles driven. So why don't we just go ahead and we'll build a table real quick. And I'm going to say, so 20 miles is $55. And 31 miles is $63.25. We could also write this as an ordered pair. You could say 20, 55, and you could say 31, 63.25. Either way is fine, whether you put it in a table or you write them as ordered pairs. And the same thing you're going to do either way. Here we need to find out, well, how much did the y value increase? Right? It was 55, now it's 63.75. So we want to subtract those. And when you subtract them, you find out this is an increase of 875. And if we go from 20 miles to 31 miles, that's an increase of 11 miles. So our rate of change, our change in y over a change in x, is 8.75 divided by 11. And so if we divide that, we get now let me check my math real quick. 63.25 minus 55. 25. Yep, I did a math thing wrong on my calculator. This is 25. When I did the division of 75, it did not come out very nice. And I tried to make these problems so they work out pretty well. They have to work out nice for it to be a valid problem. Now divide that by 11, and we get 0.75. That means it costs 75 cents a mile. Well, what if we did this using the y sub 2 minus y sub 1 over x sub 2 minus x sub 1 equation? So this would be 63.25. It's the same math that we did with the table, so minus 55. And this would be 31 minus 20, which is going to be the 825 over 11, which is going to give you 75 cents. Now that we're done, and we know that the rate of change is 75 cents, that's the cost per mile, what's the start value? What did it cost for them just to pick you up? So there is a cost associated beyond the per mile cost. We want the start value cost. And so for this one, backtracking is not going to work on the table. If I go back 11, that's going to put me at 9. If I go back 11 more, that's negative 2. So this table won't show 0 the way it is here. Now I could use the 75 cents, and I could make another table and then go to 19 to 18 to 17 to 16 and backtrack all the way to 0, but that does seem like a lot of work. Since we do know the rate of change per mile, you could do that. But I think the easiest way is to start with your y equals mx plus b equation, plug in your rate of change, which we know is 75 cents, and then choose an x-y combination to plug in here. So I could either use the 20.55 or the 31.63.25. It makes sense to use the one without the decimal values. So let's plug in 20 for x, because x is the number of miles, and let's plug 55 in here. So now we're going to go ahead and solve. So we have to do 20 times 75. Do that on your calculator, you get 15. And now to solve for b, we need to do flipping. 15 flips to the other side, so we get 55 minus 15. And when you do that subtraction, you get 40. So 40 is the start value. Now, the goal here is we want to find a linear equation that represents this situation. And so now that we know the rate of change and the start value, we should be able to do that. So y equals 0.75, that's our rate of change, x plus 40.